Okay, I'm going to finish up our quick look at regression here. This example. There's from our regression guidelines. There were 8 parts, eight tasks I might ask you to do on a test or quiz. And the part 1 of our linear regression video series is a video series. I like that. We discussed items 1 through 4. In this video, we're going to discuss items 5 through 8. The problem, again, similar to the part 1, is La Quinta, the hotel chain, trying to determine if there's a relationship between operating margin at a potential location, it's at all potential locations, and a number of variables. The variables that we chose to look at, to review, were, let me go to my pen, were operating margin and the total number of hotel rooms within 3 miles of the location. Thinking that might be something that's related, a competition related to profitability. Okay, in our regression, using Statcrunch rather, we constructed a regression model. And what I'm going to do now is focus on the last 4 items. Here's the number 5. Fully describe the relationship, the strength of the relationship of the linear relationship, and that would be between operating margin and number of hotel rooms. There's 2 ways to measure strength. One we spoke about in class, and the other way is it's related, but this is a more versatile approach because it's not restricted to linear models. You can actually look at things that are nonlinear. All right. So from our regression model, we had a correlation coefficient of negative 0.47, which we said was moderately strong. The correlation coefficient is something that's really appropriate to talk about for linear models. If you want to look at different types of models, nonlinear versus linear, and say, well, which one's the best? The better measure of that is R squared. And R squared is the square, essentially take negative 0.470329 and square it, and you get essentially about 0.22. So I'm going to go back to the problem itself, and we said our R squared is 0.22, at least to the nearest hundredth. And it turns out that that gives us a percentage of the variation. And remember, variation is, oh boy, what an awful line, but you get an idea. Here is our regression line, and here is a point off of the line, and this distance here is our error from the model. But we also have, it'd redraw our model, it didn't want to stay there. We also have the mean of all the y values, which is right here. So when we draw this total variation, the total variation from the mean of the y values, remember there's lots of other points who have different y values like that. We've got 2 parts. We've got the variation that's explained by the model. Let me put that in a different color, sorry. There you go. Variation explained by the model, and variation that's called unexplained. This 0.22 says essentially out of all of the points we've got, what percent of our total variation can be explained by the models attributed to the model. So this is 0.22, or, let me go back to blue, 22%. So what I can say is that 22% of the total variation, variation in operating margin can be explained or is attributed to by the regression model. In general, the more variations that's explained, the better the model. Okay, let's go on to our last three items, which are actually fairly quick, even though there's three of them. The first one says choose an appropriate predictor value, and then use the regression equation to construct a point estimate. And a point estimate is when you plug the x value, the predictor value, into the equation of the line. All right, so what I'm going to do is go back to my Statcrunch, and I'm going to give me an option, and when you go to pick options, let me move this down so you can see it. There you go. Pick options for linear regression, edit, and if you go down a little bit farther here, you'll see you can pick a predictor value. Now you say, first of all, what's appropriate? Because that's, if you notice, the first part of the sentence is if appropriate. So what I need to do is I'm going to go back to the equation. Appropriate means that it's something that falls within this range. We've got a range of about from 1,500 hotel rooms nearby until about 4,300 hotel rooms. So we could pick something within this range, which is called interpolation. Let's say we want to predict we are looking at a particular location that has 2,700 hotel rooms nearby. So go back to my options, edit, and I want to make a prediction. I want to predict the y value, the operating margin for 2,700 hotel rooms. Our confidence interval for parts 6 and 7 is going to be 95% our confidence level. And I compute. And what Statcrunch does is it gives me the same thing I had before, but just gives me one additional table, which is down here. The predicted value is 2,700. 4806. Remember that. 4806 is my predicted y. On a test or quiz, what I often do is I often blank this out. So I think this predicted value is something you should need to know how to do, or you should know how to do by hand. What it is if I go to 2,700 and go up to the y value, it's that equation of that line right there. Okay? So the equation of the line is the y value of that line would be my predicted value. So if I go back to remember 4806, I think it was, just trying to remember. Remember our equation of our regression line, we said was operating margin equals 70.03 minus 0.008 times the number of hotel rooms nearby, which I said is h. For our predictive value, which we said is appropriate because it's within the range of observed values, we'll say h for our predictive value is 2,700. When I plug 2,700, there you go, into that value for h, I should get an operating margin of 70.03 minus 0.008 times the predictor, 2,700. Multiply these first for the order of operations, and I think you might want to do that. You're going to get slightly different, because I've rounded off. You're going to get something that's slightly different than what the Statcrunch presents, but it should be about 48.03%. So that is our point estimate, a single prediction of the operating margin for a location that has 2,700 hotel rooms within a 3-mile radius. Our last two items, and again I said these will be fairly quick, but go back to Statcrunch. The first one, I'll go back to the question. Again, choose an appropriate value for the predictor, which said 2,700 is appropriate. Use Statcrunch to construct and interpret a 95% prediction interval for the response variable for our operating margin. And a prediction interval is a interval for essentially a particular location that has this number of hotel rooms nearby. So if I go back to my Statcrunch results, the prediction interval is over here. It's given a PI 31.31 or 32 to 61.8. So 34.32 to to 61.8 is my PI, my prediction interval. Go back to my Statcrunch or my PowerPoint. All you've got to do for this problem is identify the appropriate place on the printout. I keep forgetting. Boy, I must be getting old. 34.32 to 61.8. Remember that for me. So what I want to do is construct a sentence. So we are 95% confident that the operating margin for A, and I'm going to add this just to emphasize, for a single location with 2,700 nearby hotel rooms. Hoti, there you go. Hotel rooms is between 34.32 and 61.8. So let's go back to our PowerPoint. 34.32% and 61.8%. And that is our interpretation of the prediction interval. Lastly, this problem says, use Statcrunch to construct a 95% confidence interval for the mean response. And that's how you can tell you've got the mean response is a confidence interval for the mean is on your Statcrunch is the CI, the confidence interval. So a prediction interval is for a single location. The CI is the mean of all locations that would have this trait. 46.44 to 49.68. A prediction, how many times I'm going to need to look back at that to remember it? 46.44, 49.68. Let's go back to our PowerPoint. The interpretation is very similar. We're 95% confident that the mean operating margin for not a single location, but for all locations with 2,700 nearby hotel rooms is between and 46.44 and 49.68. 46.44% and 49.68%. So again, confidence interval, we're predicting for a mean, which is a prediction for the mean operating response for all locations.